Okay, welcome back. It's getting a bit late. It's afternoon already. We're still strong and very curious about the next talk. Before that, I must remind that Pact is monitoring you, the partner Pact, and looking for your active behavior during the talks, asking questions, chatting, showing all kinds of signs of being alive. That will be appreciated with free ebooks. But now over to Christopher from IBM, somewhere from the New York, as I just learned, who's gonna tell us a bit what to do with the hell of containers in production and other environments, I assume. Christopher, it's your time.
All right. So,
Okay.
thank you. Hopefully, everyone can see
Yep.
the screen.
Yeah,
Um,
that's great.
all right. So, my name is Chris Rosen. I'm the Director of Product Management in IBM Cloud. And today, what we want to talk about is the longest title that I could come up with, and it's easing the agony of operationalizing your containerized apps in the cloud. This is something that comes up a lot when I talk to customers that are in a wide range of stages in their journey, their transformation to cloud native and cloud adoption. So we'll kind of walk through some of the areas in which will be important for you to consider as you progress through your own cloud journey. So the first thing that I want to do is kind of take a step back in time. This movie hopefully resonates to this audience as well. Back to the Future, when they go back in time. So we're going to do that from a technology perspective. You all may recall a time when containers were as easy as just simple Docker run and then name of container. And now look, I'm a uh, container developer. I'm running my first containerized application. It was very simple. And now I'm up and running, and I've opened myself to a whole new world of challenges around observability and security and ongoing lifecycle management of this brand new cloud native application. So, as I said, everyone's journey begins with that single container. And obviously, with one, it's pretty easy. So, at first, it's easy. I can add 1, 2, 5 different microservices within my application, and that's sustainable. It's manageable in that given environment for me to manage it as is. But the reality is that very soon this can become very overwhelming and daunting because now I've got multiple applications. I am adding more and more microservices within that application. And as you can see, now I'm overrun by the number of containers that I'm trying to manage in that environment. Several years ago, if we think back to a time when it really was quite a debate whether technology wise we were going to choose something like Swarm or Mesos or Kubernetes. Obviously, when we fast forward to now, the community, the ecosystem, you have chosen Kubernetes as that orchestration level, that distribution that will help manage and streamline and handle updates and things like that within your deployments. Coincidentally, I was in KubeCon Europe last week in Valencia, Spain. So there were 7,000 of my closest friends there talking about new projects and Kubernetes and things. So a lot of what we'll talk about here is very applicable to the conversations that I've had last week as well. Now, in IBM Cloud, if you're not familiar with our platform, we launched IBM Cloud Kubernetes Service, or IKS for short, back in May of 2017, where we're very focused on not only the day one instantiation of that cluster, where there's a lovely UI, you can point and click through and create your first cluster, but that's the easy part. It's really the day two onwards. How do we ensure security updates, operating system updates, vulnerability remediation, or anything in the ecosystem within that Kubernetes stack as updates become available? And that's where we're really focused is think about raising the line of responsibility for our consumers, which are typically developers, that they want to focus on building applications, running cloud native apps, innovation, not running and maintaining security and compliance and updates with the community. So that's where the operational burden comes into play, where we're going to handle those things for you. We've been the first cloud provider to have the latest and greatest upstream community support. And we do that by working very closely in the ecosystem. So if there is, a bug, a regression, a performance in the community, we fix it in the community. And then we consume it within IBM Cloud versus, forking and creating some weird situation where we drift from what the community has available. And then obviously there's the power in numbers, the power of the community to be able to innovate and add capabilities and security and hardening of that platform out in the open and in the ecosystem. So let's go through and talk about, that journey that I mentioned earlier. And like I said, day one, the first step is creating those clusters. When we go through the steps of what that looks like, and of course you would typically do the UI once. Then you're going to drive through some automation, whether it's the CLI, the API, some infrastructure as code like IBM Cloud Schematics, which is based on Terraform and Ansible, to automate that, to integrate this process to your CI/CD pipeline, where you may deploy a new cluster, deploy some workload, and then shut it down once you've gone through all that testing. But in the UI, the first thing I'm going to do is select, the version of Kubernetes that I want, the infrastructure of choice, where do I want it to run? So now we're looking at number 2. By default, we want a multi-zone cluster with highly available masters, which will now distribute the master nodes and worker nodes across 3 physically separate data centers in that region. And we do that, again, building in those operational characteristics to the cluster such that if there is some catastrophic top-of-rack network outage in one of those data centers, that's okay. The API is still accessible in the other 2. My workloads are still accessible in the other 2. Similar construct when we're going through a rolling update from Kubernetes 1.21 to 22 to 23 to so on and so forth, that we do so in a rolling manner. So that way your end customers never feel an update is taking place. They can always access the API or your applications running in that cluster. Number 3, we create our default worker pool. And this is where I pick a flavor or t-shirt size within that instance, the number of workers that I want in each of those zones or data centers. And of course, maybe I create too large or too small initially, and I can add a second worker pool to that cluster, and then I can scale up or down based on what my workloads require. I could use auto scaling to automatically, if I exceed some threshold for a given duration, to add additional worker nodes and then scale it back down. So that way we can dynamically provision and deprovision those resources. We use Lux encryption on every secondary disk, just adding another layer of protection. I could have both private and public endpoints. I could create an air-gapped cluster, so there is no front-side network connectivity. And a lot of my enterprise customers that only want to access this cluster from their data centers using direct link or some other VPN technology, they do that, and it really minimizes the attack surface because there is no front-side network connections. And then in number 4, we've got a little infrastructure checker, permissions checker. Maybe I'm the administrator of the account. I invite you to the account, and I've not given you all of the right access to actually provision this cluster. This would let you know right out of the gate versus trying to deploy something and then failing and digging around to understand what has actually happened. So this, once I've made all my selections, I click create, and then we'll go off, we'll provision the masters, the worker nodes in that cluster, and I'm up and ready to go. And then I've got a native Kubernetes experience. And across the bottom, of course, if you want to drive that from the CLI, it's very simple to do the same thing that we've just point and clicked through the UI. There we go. So now we talked about how easy it was to deploy that first cluster. And you can see our manager here on the right-hand side, he looks angry because he wants to understand things like, okay, it was so easy to spin up, but what's our spend? Who has access to all of those resources that we've provisioned in the cloud? How do we maintain currency? How do we make sure that we've got the right security patching? If there's a new log4j or some other vulnerability that comes out, how do we make sure that we've got it secured and hardened, and that my trusted personal data, my applications that I'm running are protected? And then how do I get troubleshooting and insights, observability from a metrics and a logs perspective, and understand who's doing what? So as easy as it was to get started, that then opened up this Pandora's box of all of these concerns that we may have for running that workload in the cloud. So that's where we think about day 2 onwards. It really is about simplifying the operations, building in those capabilities in this very fluid, dynamic environment, cloud, Kubernetes, containers, and cloud native workloads. So the first thing, and we'll go through some of these capabilities that we'll talk about how we get those insights into that environment to really answer all of the questions, the challenges that we had on the previous chart. So the first thing that I would always advocate to my customers is an automated CI/CD pipeline. If you have tools of choice already, and there are a lot out there, maybe you build your own Jenkins, there's open source projects, there are vendor projects. Either way, that's fine to me. What I really want and where I'm focused is that you have that automated CI/CD pipeline, so that way everything is source code controlled. We've got the right access controls. No one wants Chris Rosen pushing an update out to our production applications. So we're going to stop that train. We want insights to vulnerability remediation. If we've pulled an image from a public repository, we want to make sure that there are no vulnerabilities before we're allowed to deploy that workload. So if you don't have DevOps tools already, in IBM Cloud, we've got some continuous delivery tools, some CI tools, with a variety of Git repositories and source code checking and code risk analyzer, as well as the image scanning, which will introspect every layer in each of those images for those vulnerabilities. So now we've automated our deployments. We've got our cluster up and running. It's really about getting metrics, insights into the entire range of that, from the cluster, the infrastructure, the worker node level. And then as we move up the stack and we think about those cloud native applications, as that complexity increases, we really need insights to the metrics of that. How are they performing? Is there one particular microservice that needs additional instances to handle the workload? Or is there a memory leak somewhere that's consuming all of the CPU or the memory within that particular workload? So IBM Cloud Monitoring gives you that single source of truth where I could send all of my metrics for all of my clusters, regardless of where they're running. Maybe some are in the IBM Cloud, some are on-prem, some are elsewhere. But then operationally, I've got one source of truth. I've got one place to create my custom alerts, my custom dashboards. I could integrate with Slack or emails or text alerts when I exceed a certain threshold, and I notify the right teams to go ahead and investigate and take the right action. The next thing are logs. Now, logs are generally not super exciting, but in reality, the logs are going to give you the insights to help troubleshoot and understand performance issues or things that are going awry in that environment. The thing that I like about our logging solution is it's tightly integrated to the Kubernetes cluster. So when I'm logged into IBM Cloud, I'm looking at a particular Kubernetes cluster, and I click the logging button, it's going to take me in context of that particular cluster. And then I see all of these logs. But what's really great is that I can use natural language. Across the bottom, it may be a little hard to see, but I can search for an error, and then it says jump to timeline. And maybe I don't know exactly when, but we started to hear complaints about 5 hours ago. then it will jump me into that point of time looking for error 5 hours ago, and I can grab that line and I can send it to the right development squad that owns that particular piece of the application and have them give them that starting point to start troubleshooting it. So similarly, I've got one source of truth for all of my logs. I've got custom dashboards and alerts with the same integrations through webhooks to Slack or email or however your teams like to receive these notifications. Now, I mentioned this earlier when we were talking about deploying your first Kubernetes cluster. This is what it means for us when we talk about highly available multi-zone cluster. And that's the default. Maybe I've got a dev test cluster and I don't need this amount of resiliency, and I could definitely deploy it to a single zone region or one data center where all of the masters and workers are in one given data center. But to really increase the availability, to be able to get the 99.99% financially backed SLA, which is industry leading when you compare that to the other cloud providers, then I want this multi-zone. So this example is using US South in our North American MZR or multi-zone region. And in the 3 different data centers, I've got 3 worker nodes in each. Sitting on top of that is a application load balancer. So that way, again, that's the piece that will come in, take incoming requests, and distribute them to the different ALB in each zone based on resource availability and, of course, availability of the ALB itself. Now, from an upgrade ongoing lifecycle management perspective, if we start in the upper left here, this is where I've got an overview of all of the clusters running in my account. And you'll see I've got a mix of upstream Kubernetes. I also have some OpenShift clusters in this account because we have, in addition to IKS, we've got Red Hat OpenShift on IBM Cloud, which is our managed OpenShift distribution. Maybe I want all of the additional value in OpenShift, and then it's the same look and feel, the same platform integrations, whether I want upstream Kubernetes or OpenShift. But once I have that cluster selected, now we look in the middle image here, I can go in and I can see that this cluster is at 1.21. Maybe I'm ready to update that. And what I would do is select everything and say, yes, I'm ready to go. Now, the reason we want you to determine when is the right time to upgrade is because maybe the community has deprecated APIs that you use, or maybe you have some applications that are not really cloud native, they're more monolithic that you're just containerizing. So we want you to be cognizant and aware that an upgrade is taking place. But once you say, yes, I'm ready to go, then IBM Automation takes care of the rest. We'll take that first worker node or that zone or X percentage based on what you define in a config map, drain all of the deployed pods from it, reload it top to bottom. That's how you get OS updates, vulnerability remediation, Calico is our network overlay, or Kubernetes. Any of these updates, once it's back online and healthy, then we move on to the second node, third, fourth, so on and so forth. So we'll roll through that cluster such that in your cloud native application, you don't know or feel that an upgrade is taking place. So it really simplifies, again, raising that line of responsibility so you as a developer can focus on innovation and building the things that you want, not managing lifecycle of your clusters. The next area is around who has access to what. So this is where I can be very fine-grained and prescriptive to the amount of access that I want to give someone. So here's a user in my account, and I could give them full administrative access to resources. I could let them take billable actions, meaning I can deploy new clusters or provision additional worker nodes in that cluster. I could give them access to just a namespace in my Kubernetes cluster. Maybe it's read-only, maybe it is deployable. But depending on the user, the group, the team, I can then give them the exact access and controls to that environment based on what they require. Maybe they're an auditor, So they just need read only on all of the resources. So I can give them that access and control who has access to what. Of course, I wouldn't go through and do this user by user, but this is the example. I could also create groups of users to where I've got one large Kubernetes cluster, and then I'm giving different namespaces access and quota. That way I can really leverage the resources very efficiently in that account. Within IBM Cloud, we've standardized all of our offerings to run in Kubernetes. And I do that not so much to brag about how great our services are and how much they run on top of the Kubernetes service, but to really kind of highlight and articulate the breadth of services and workloads that are running in that environment. It's clear you would think things like cloud native applications, like our billing systems, the console, things like that, that are really fit nicely into containers and cloud native workload. But we also have other things like IBM Cloud Databases. So this is very resource intensive workload. And our customers that are using a database, they just want Mongo, Redis, Postgres, etc. They don't know or care that their database is running on our Kubernetes service, but the database team does. They let us handle auto scaling, lifecycle management. They focus on DBA things, new versions of Redis, or scaling out the database, or backing up that database for the customer. So again, it's just another higher level abstraction for those teams to provide value to their end customers. And other things like the weather company or our monitoring and logging solution, IBM blockchain, all of these things are standardized on the Kubernetes service. So now, okay, we turned our manager around. He's happy. He's got all of the insights that we needed to solve by moving that workload to cloud, because we're providing the automated CI/CD pipelines. We're providing very fine-grained prescriptive access controls to those resources. We are giving managed Kubernetes with different workload isolations, including bare metal servers if I need that amount of isolation. We've got the latest and greatest from the upstream community. We've got our monitoring and logging and activity tracker to get insights to who's doing what. We're using different key management system. If we think about, every cloud provider has a bring your own key capability. And we've got that in IBM Cloud called Key Protect, where you own the keys, you can revoke them, so on and so forth. But the thing that's unique in IBM Cloud is what we call our keep your own key capabilities based on our crypto services technology, which leverages FIPS 140-2 level 4 encryption. Maybe you're thinking, well, Chris, that sounds really nerdy. What does that actually mean? And it means this. In the other cloud providers, in a bring your own key, they have a policy assurance that they won't access your applications or your data, but they could. Only in IBM Cloud, with our crypto services technology and that level of encryption that we use, is there a technical assurance that we, IBM, our developers, our support teams, our site reliability engineers, do not and cannot access your application. So that's really the technology foundation of trust for our key customers, whether they're in financial or healthcare or retail. Everyone wants to protect their data, especially when you think about cyber threats that are very real right now. Only in IBM Cloud do we have that bubble, that enclave around all of your applications and your data to ensure that others do not have access, including IBM. So at this point, we were happy, but wait a second. Maybe not all of my workloads are ready to move to cloud yet. And that could be for a number of reasons, that when I talk to customers, that things are not ready. Now, if you're born on the cloud, that's a whole different discussion. But in our discussions with IBM, with our customers, the heritage banks, we've got the top 10 banks in the world. We've got 9 of the top 10 airlines. All of these customers that have this legacy, this heritage of infrastructure may not be ready to move all of that to cloud yet. Maybe it's because they don't want to lift and shift to cloud. They want to modernize it before they move it to cloud. Maybe there's sovereignty issues. And again, this has become very prevalent here recently, where I want everything running in my country where I live. It cannot leave. My data cannot leave the borders of my country. Maybe I need multi-cloud consistency. I'm running in IBM Cloud. I'm running in my data center. I'm running on AWS, Azure, Google, Alibaba, so on and so forth. So I need consistency because they may all have a Kubernetes service, an OpenShift service. They all have their own levers in which they deploy those things. So maybe I want a higher level abstraction for consistency. And then lastly, maybe I want a public cloud consumption model in my data center. So when we think about the model today, if I purchase software from a vendor, I'm going to buy some bulk amount, some allotment, and it's generally 1 year, 3 years, whatever the terms of that contract are, but I need to invest significantly upfront in that. And if I see value and I consume all of that, fantastic. If not, then I'm going back to the vendor and I'm looking for a reversal in that contract to try and recoup some of those costs. So I talked to a lot of customers that they like cloud consumption characteristics. I deploy it, I pay for it while it's deployed. When my project is done, the team is done, I turn off those resources and I stop paying for those consumption. So how do I get that in my own data center? Last year, in the March of 2021 timeframe, we launched something called IBM Cloud Satellite. And this is our response to what Gartner refers to as distributed cloud. Other analysts will call it local cloud as a service, but it's all the same premise. It's about taking a cloud provider's fully managed, from our SRE team, all of the lifecycle, the updates that we've been talking about for the past 30 minutes, bringing that outside of the confines of IBM Cloud infrastructure and running it elsewhere. That elsewhere could be your data center. It could be in the edge. It could be in a retail location, manufacturing plant, or other public clouds infrastructure as well. So now it's giving you the flexibility to have a higher level abstraction, to pay for the elasticity based on the workloads that are deployed, to give you that consistency from your data center to public cloud consumption. We also have gone through, and we didn't touch on this earlier when we were talking about IBM Cloud, but we've gone through what we call financial services cloud validation. And a quick history here. We've been working, we started out with the 8 largest banks in the world, where we created this open source consortium where we're talking about what are the controls that you have to implement? How can we automate that and bring attestation to those controls so you can move that workload to IBM Cloud? So in IBM Cloud, we've gone through this compliance, this validation. That ecosystem has now grown from those 8 largest banks in the world to regional banks, local banks. We're over 100 at this point that participate in this open source group to provide those insights. Now, your controls may be slightly different than someone else's controls. So we'll stack them up next to each other and figure out what the delta is so we can implement those right controls that give your CISO, your security teams, your risk assessment teams, the comfort to be able to move that workload. So now we've brought those FS Cloud controls to IBM Cloud Satellite to where we can bring that to other infrastructure. Like I said, we can bring those controls, that hardening, into your data center as well. The first thing that I would do is create right here in the middle is what we call an IBM Cloud Satellite location. A location it's essentially a mini IBM Cloud region. And we're working with a number of customers with different scenarios where, based on the use case, it could be resources in their data center. It's very infrastructure agnostic, meaning that maybe you have infrastructure already. Well, we can leverage that. Maybe you don't have infrastructure and we've got an IBM Spectrum Fusion HCI stack. We've partnered with Dell, Lenovo, Cisco, etc., where you can order the full cloud in a box if you want, roll something off the truck, power it up, network it up. Now I've got the hardware stack, and then I layer on IBM Cloud Satellite on top to that location. Then I'm bringing things like my managed OpenShift offering. I'm bringing databases, object storage, key protect, event streams, and code engine all to that satellite location. So now think about this. Fully managed platform as a service offerings running in your data center or running in these far edge locations, where we've worked with a manufacturing company to deploy satellite into their plant, and using Maximo visual inspection will introspect the production line. And if there is something that's gone awry, we can catch that very early on. Maybe a robot is malfunctioning or whatever the case may be. We can identify that and stop production right then, versus rolling out 20 cars and then figuring out that something is not quite right. And then that's going to cost significantly more to go back and fix that situation. So instead of, taking video, sending it to the cloud for processing, and then sending an alert, we're bringing the processing to that manufacturing plant and handling everything in real time. We're removing latency. We're improving the operational characteristics of it. And that was so successful that this particular large car manufacturer in the United States has rolled that out to over 25 plants to be able to provide those insights and that introspection. Another example, and this came up the University of Mainz in Germany, where during COVID, or early on in COVID, I should say, they had some challenges. There were new things that they needed to develop, like how do we do COVID testing? How do we track that securely, quickly? Once vaccinations became available, it's how do we track that? How do we ensure that the right, depending on the vaccine that you get, the right distance between doses, boosters, so on and so forth. And the data is very important to live and never leave Germany. So we deployed satellite locations to initially 12 different hospital locations to be able to run these OpenShift clusters, to run these cloud native apps. Think about the edge, these places where, the manufacturing plants, the hospitals, retail stores for kiosks, shipping locations. These are generally not places where we have a lot of Kubernetes or OpenShift or container expertise. These skills are very expensive. They are hard to come by. I know here in the US, and I anticipate worldwide, that there's a lot of attrition when we think about the resources that have skills in Kubernetes. So how do we manage that? And that's, again, where satellite is coming in and solving this, bringing this technology, these managed services, to these locations where they may not have it, bringing that line of responsibility up. So these guys can focus on the innovation, the customer care that they need to be able to provide for their customers. So it's really improved efficiency, the ability to use chatbots, engage with the doctors, the nurses, the end patients in a much more meaningful manner than they could previously do so. So we're really excited about the types of opportunities and challenges that we're solving with this technology. Because at the end of the day, technology is great, but if we're not really solving your line of business problems and objectives, then the technology is useless. So we're really seeing a lot of powerful, meaningful, advantageous uses of this technology to streamline those challenges. So with that, I'd like to thank everyone for your time. I appreciate it. I know it's a little hard in a virtual event, but again, thank you very much. My email address is here, my Twitter handle. If you have follow-up questions that we may not get to here, or maybe you don't want to ask them in this context, then that's fine as well. I encourage you to reach out, send me an email, drop me a DM on Twitter, and glad to discuss that with you. So with that, I'll pause and see if there are any questions in the
Yeah,
chat.
let's give it a bit of time, and we're waiting for questions. What can we expect next in this context?
So I think some of the areas, we're continue to focus on new tools, simplification, higher levels of abstraction, bringing more solutions, more comprehensive things. Meaning that if you go to IBM Cloud and you look at all of the tiles in the catalog of over 200 services, it's pretty daunting. Like, how do I actually get started? So we're developing something called what we call blueprints, where it's essentially a reference architecture where I can have a number of services to go into that solution. I can tweak it, I can modify it, and I can deploy it all in one motion. And now I've got everything that I've talked about with the monitoring, the logging, the Kubernetes cluster, the DevOps tools. So it's really simplifying the consumption of those services.
Okay, and what will be the possibilities to modify it? Everyone wants to have their own custom thing, but doesn't want to reinvent the wheel.
Absolutely. And so we think about these as, essentially starter kits. And it's really to point you in a direction of possibility. So maybe I find a given reference architecture and 3 of the things are not applicable to me. I don't need that. I've got my own monitoring and logging tools already. I'm using, New Relic, Datadog, Splunk, so on and so forth. There's a million tools out there. So maybe I don't want to use IBM Cloud Monitoring and IBM Cloud Logging. So we remove that from this reference architecture and I plug in my own solutions. And now I've got my own customized reference architecture, which I built. I used 80% of it from IBM, but I've modified it to really make it my own. And now I can deploy it. I can give my teams access to that template, and it simplifies their deployment of those environments going forward.
Mm-hmm. Yeah, that sounds amazing. Okay, that's going to be very interesting. I don't see any new questions coming in. It seems that everything was loud and clear, which is plausible. So thank you, Chris.
All right. Thank you very much. I appreciate it.